Right. This lesson is about simplifying, multiplying, and dividing rational functions, which sounds like a lot, but once you understand the concept for simplifying, you're just doing the exact same thing for all the other ones. So it's no big deal. Okay. On this first section, they want us to not only simplify, but also find the domain. And the domain is the set of x values. So we kind of need to solve for x. But really, in these problems, you can plug in anything you want, except you can never divide by a zero. So we can plug in anything we want except what makes the denominator zero. So to find the domain, we have to set the denominator equal to zero. And to solve that, we're going to do that by factoring. So the two numbers that multiply to -10 and add to 3 would be +5 and -2. So when we solve, we get -5 and +2. So our domain is all real numbers except -5 and 2. Okay. Now, to simplify it, even though it kind of seems like two separate problems, we've done half of the work. To simplify it, we have to factor both the top and the bottom. Well, we already know the bottom factors to x plus 5, x minus 2, and the top factors to x plus 2, x minus 2. Now, when these expressions are in a parentheses, those parentheses become a group, and we cannot separate our groups no matter what. So we can only reduce if we have matching groups. Well, these both have an x minus 2, so they're going to cancel. So our final answer is going to be x plus 2 over x plus 5. And because there was only one group on the top and bottom, you don't need to write the parentheses, but it would not be considered wrong if you do. All right, let's try this again on number 2. So to find the domain is any number except what makes the bottom 0. So we have to set the bottom equal to 0. So to factor this, first we have to take out the GCF of x. So that gives us x squared minus 2x minus 3. Then we can continue to factor. And the two numbers that multiply to -3 and add to 2 would be -3 and 1. So when we solve, x is 3 and -1. So a faster way that we can write this is this symbol here means real numbers. And then except means everything but, and then we put our two answers, 3 and -1. Okay, so the simplified form, we have to have the top and bottom factored. So we already know the top factors, the bottom factors to this. We now have to figure out the top. So the two numbers that multiply to 1 and add to 2 would be 1 and 1. So matching groups can simplify. This x right here is not a group because it's not in parentheses. Sometimes you're going to have just a number or a variable out to the side. Those can only be reduced if there's other numbers or variables that are out to the side. You can't reduce, even though that's not an official term, this x I like to call an individual, and you can't simplify an individual with a group. So when I write my final answer, on the top, I just have the one group. So I do not need to include the parentheses. But at the bottom, I have more than just the group. So I do need to write the parentheses. But notice that I didn't distribute that x. I just leave it in its factored simplified form. Okay, now when I was doing this, I was kind of doing double the work because you got to factor it no matter what. So let's just start by factoring everything and then figuring out which part is the domain and which part is the simplified answer. So if I factor everything on the top, this is going to factor to x plus 6, x minus 6. And on the bottom, this is going to factor to x, two numbers that multiply to -24 or add to -2 would be -6 and 4. Okay, so here we've got matching groups. Now be careful, your simplified form is x plus 6 over x plus 4, but your domain you have to get from the entire bottom. So the domain is going to be all real numbers, except it can't be. Sometimes they say that's the empty set. So we might be better saying x cannot be 6 and -4. Okay, so you can do it with less work as long as you remember you got to figure out the domain from the original factored problem. All right, we don't have to do any domains anymore. We just have to do some simplifying. All right, this one we need to find the product. And if you remember, when you're multiplying fractions, you multiply straight across the top and straight across the bottom. And that's what we're going to do here, except we're going to try and reduce first, just like you would with fractions. Now, the numbers, I kind of think of these as two separate realms. One is the numbers, one is the variables. So with the numbers, the 8 and the 4, I can reduce this to 1 and 2. Now, a lot of you can see what the variables do, but I'm going to write it out once the long way. So we kind of have a visual, but we don't really always have to write this visual. So on the top, we have 4x's. And on the bottom, we have the 4x's over here and another x over here. I can cancel 1x for x. And so I'm left with just 1x on the bottom. So I have the 2 on the top and then 1 times x on the bottom. Well, 1 times x is just x. And so that's my answer. All right, let's do this again over here. We got a lot more going on. When you reduce the numbers, you can reduce at a diagonal or you can reduce straight up and down. So at a diagonal, 10 and 25 are both divisible by 5. So I'm going to call this 2 and this 5. And then 6 and 12 are also divisible by 6. So this is going to be 1 and this is 2. Now, if I could reduce up and down, I could continue to reduce. What I cannot do is reduce side to side. So the 2's that are both in the numerator will not reduce. Okay, so on the top, I have 2 times 2, which is 4. And on the bottom, I have 1 times 5, which is 5. Now with the variables, we'll just take it one variable at a time. With the y's, there's 3 on top and 2 on the bottom. So think about this in your head. If I cancel, I'm going to have 1 y left, and it's going to be on the top because I started with more on the top. Okay, with the z's, there's 2 on the top and 4 on the bottom. So when I reduce, there's going to be more on the bottom, and there's going to be 2 of them. With the w's, I have 2 on top and 1 on the bottom, so there's more on the top. So when I cancel, I get 1 on top. With the x's, 2 on top and 3 on the bottom, when I cancel, I'm going to get 1 on the bottom. And there's my answer. Okay, now for these problems here, we've got to follow an order. When it's the difference between example 1 and 2 and the rest of them is these didn't have addition and subtraction signs. And when they don't have addition and subtraction signs, you just start reducing and going to town. But when they have addition and subtraction signs, we have to do this. We have to factor first, simplify, and then multiply. And you've got to go in that order. Now, look at number 3. This looks terribly complicated, but do you know what the best news is? It's already factored, so you don't have to do any work. So all we're going to do is cancel matching groups. So the z plus 4s, they cancel, and you can only cancel them 1 for 1. Z plus 1, those cancels. Now, these both have 6's, but one's a plus and one's a minus. They don't cancel. And 3 and 5 is not going to work. So on the top, I've got a z plus 6 and a z minus 5. And on the bottom, I have a z minus 6 and a z plus 3. That's it. Okay, number 4. Number 4 is not factored. And I know it's not factored because I don't have parentheses. So I got to factor everything, simplify, and then write my answer. Okay, so on the top, the two numbers that multiply to 11 and add to 12 would be 11 and 1. B squared minus 9 is going to factor to b plus 3, b minus 3. b plus 9, the exponent is an invisible 1. It can't factor further. It's done. So this is just b plus 9. On this one, the two numbers that multiply 99 and add to 20 would be 9 and 11. Okay, now, because there was nothing we factored, this becomes a group. When something is attached with plus and minus, it becomes a group, and so we can't separate it. So now we're just going to cancel matching groups. So the b plus 11s cancel, the b plus 9s cancel, and there's nothing else. So on the top, I have a b plus 1. Don't need parentheses because it's just one group. But again, if you wrote them, it's not wrong. And this, I have b plus 3 times b minus 3. And we're done. Okay, number 5. Number 5 is interesting for this part over here. It means this quantity squared, which means there's 2 of them. So if I was to write it out, this would be x plus 4, x plus 4. And remember, we can only reduce one group at a time. X squared minus 16 is x plus 4, x minus 4. Over here, this would be what, -7 and -2. And this would be -7 and 4. Okay, so these can cancel, but also these, because it's 1 for 1, and these can cancel. That's it. So now on the top, I have x minus 2, and on the bottom, I have x minus 4. Do the 2's and 4's cancel? Absolutely not. Because they're attached with a minus sign, or they could be attached with a plus sign, they can't be separated from the variable. And if they can't be separated, they can't be reduced. All right, let's try one more over here. Okay. Oh, you know what? This one should have an x. I don't know where it is, but it should have one. So to factor that, I first am going to have to take out that x, right? And then I'm going to have x squared minus, oh, this is weird. That should be a squared. All sorts of mistakes. We're fixing it. We've got it totally under control. Okay, so now it's going to factor the two numbers that multiply to 12 and add to -4 would be, oh, this is negative. Oh, would be x minus 6 and x plus 2. On the bottom, it doesn't factor, so it becomes a group because there's a plus or a minus. Times, this is going to factor to x plus 2, x minus 2. There's no plus or minuses here. Those don't factor, so those are individuals. Okay, matching groups can cancel. 1 for 1, so I cancel this one. I can cancel up and down, and I can cancel at a diagonal. What I cannot do is left and right. So the x plus 2's absolutely do not cancel. However, I want to draw your attention to this x and the 3x squared. Those are not groups. They're not groups because there's no plus and minuses. Those I called individuals, even though that's not really a term. Those can reduce. So I've got 1x on the bottom and 3 on the, 1x on the top and 3 on the bottom. So if I cancel, I would just have the 2 left on the bottom. So now when I write my final answer, on the top, I have x minus 6 and then x plus 2. And I can write another x plus 2, or couldn't I just write x plus 2 squared because there's 2 of them? On the bottom, I have 3x squared. Do these squareds cancel? Absolutely not, because here it's squaring x plus 2, here it's squaring x. Those are not matching. All right, quotient. Quotient is the answer to a division problem. Okay, so even though it looks different, it's actually just the same. And then, but the thing you have to remember is you have to flip the right one. Okay, so let's see if we can flip the right one. So when I flip the right one, I can't write today. When I flip it, the reason we do that is because it becomes a multiplication problem. And now that it's a multiplication problem, now I can reduce. Now these I don't have to factor first. And the reason I don't factor first is there's no plus and minuses. And when there's no plus and minuses, I can just start reducing. So I can reduce it at diagonal, divide these both by 5. Let's see if I can write that more clearly. And I can reduce over here. I can reduce up and down if I could, but there's nothing, but I cannot reduce left and right. So my numbers on the top, I have 2 times 2, which is 4. And on the bottom, I have 1 times 5, which is 5. My variables, I have 3 m's on top. Oh, I miswrote this when I flipped it. And 2 on the bottom. So when I cancel, I'm just going to have 1 left on the top. With the n's, I have 3 on the top and 2 on the bottom. So when I cancel, I just get 1 and it's on the top. Okay, let's try this again for number 2. It's just like multiplication, except I have to flip the right one. So I have a to the 4th bc cubed over g squared h cubed times, and then over here I have g cubed h cubed over ab squared c squared. All right, now I can reduce. A's, well, there's no numbers, so don't worry about that. A's, 4 on the top and 1 on the bottom, so I cancel. And I get 3 on the top. B's, 1 on the top, 2 on the bottom, cancel, get 1 on the bottom. C's, 3 on the top, 2 on the bottom, cancel, get 1 on the top. G's, 1 on the top, H's all cancel. That's my final answer. All right, just 2 more. These have pluses and minuses, and because they have pluses and minuses, I have to factor first. Okay, but because it's got a division, I've got to flip the right one. Okay, so I'm going to factor and flip all at one time, so I don't have to rewrite this over and over again. So on the top, the 2 numbers that multiply to 16 and add to 8 would be 4 and 4. On the bottom, my 2 numbers would be -3 and -3 times. Now this part is going up to the top. Now how do I factor that? Well, there's no exponent, but isn't there a greatest common factor? Yes, the greatest common factor is 3. So I have to take that out. On this one, the greatest common factor is 2. So I have to take that out. Now let's see if we can reduce. I have a plus 4s that cancel, and I can only do 1 for 1. A minus 3s cancel. I can only do 1 for 1. So on the top, I have a 3 and I have an a plus 4. If you have a group and an individual, the individual goes first. So I have 3 times a plus 4. Have to leave the parentheses because there's more than one thing. Over here, I have 2 times a minus 3, and I don't multiply it back out. Okay, one last one. This one, to factor, I'm going to have to take out the x. So let me do that first. And this one, I'm also going to have to take out the x. So I'm just going to do this first. Okay, now I'm ready to factor and flip. So over here, my 2 numbers that multiply to -2 and add to 1 would be +2 and -1. Here, my 2 numbers would be 2 and 3 times. Now remember, we're flipping it. So the x squared plus 7x plus 12 goes on top. So this is x plus 3, x plus 4. Over here, I have an x, and then my 2 numbers would be +4 and -3. So I can only cancel 1 for 1. So I have an x plus 2, it'll cancel. X plus 3, it'll cancel. X plus 4, it'll cancel. But notice these are not a group. These are individuals. They're not a group because they don't have pluses and minuses. But groups can also be reduced. If there's one x on the bottom and one on the top, those are going to cancel out. So on the top, I'm just left with x minus 1. And on the bottom, I have x minus 3. And we're done.